Today's lesson is on multiplying and dividing with scientific notation. So the question is, how can we use the product of powers property to multiply two numbers written in scientific notation? Let's look at an example. If I wanted to multiply 1 and 4/10 times 10 to the third power and 7 and 6/10 times 10 to the fourth power, you first multiply the numbers together and then you multiply the powers. So what is 1 and 4/10 times 7 and 6/10 would give us 10 and 64 hundredths. You can do that without your calculator. And then 10 to the third power times 10 to the fourth power is like having 3 tens written out times 4 tens written out, which we know is the same as adding the exponents to get 7. Okay, now remember to always put it in scientific notation. This might look like scientific notation, but there's a big no-no, and it's this 10 right here. That 10 is not between 1 and 9. It's got to be an integer between 1 and 9. So if we think about it, I could have this times 10 times 10 to the 7th power, which would give me 10 to the 8th power down here and bring it down. Okay? Let's go back and look at the original example. So I've got 3 and 1/10 times 2, and I'm going to multiply it 10 to the 6th power times 10 to the third power. Go ahead and try that problem. Pause the video. I'm going to go through the answer. You would get 6 and 2/10 here and times 10 to the 9th. Notice it is in scientific notation, so it's done. What about this one? Follow my steps with me. Go ahead and try it. Pause the video. I'm going to go through the steps in just a second. So if you want to try it on your own, pause first. All right, so what's the first step? The first step is to reorder them. Put the base 10 exponents together and the numbers. Multiply them out, and then ask yourself, is this in scientific notation? The answer is no because of that. Because of that 13. I moved the whole problem. All right, this would be like saying 1 and 312 thousandths times 10 to the 12th. Remember, 10 is the same thing as 10 to the first power. Okay, so we would have this as our scientific notation. Okay, the next one, let's look at some more examples. I want you to try these three. Pause the video, and then I'm going to go through the answers for each one individually. Okay? So make sure you have the video paused. I'm going to start going through the answers for the first one. If we look at this one, we're going to multiply our whole number, or not our whole numbers, clearly he's not a whole number. We're going to multiply our numbers and then multiply our base 10s with our exponents. In this case, it's a negative one. That's okay. That just means that the number is going to be a small number. Okay, this right here is in scientific notation. This right here is what we call standard form. Remember that from the previous video. All right, I want you to write down the standard form and box it in. You can leave it in scientific notation if they ask you, which they did, but then we can place it in standard form as well. Okay, so I'm going to show you both forms again. For number 2, we do the same work steps, except this time it's 4.5 times 1 and 10 to the 2nd times 10 to the 5th, which is 10 to the 7th. This is scientific notation, which is perfectly fine, but if they ask you to put it in standard form, we put it like so, moving the decimal point 7 places, okay? Let's look at the last and final example. Number 3, 4 times 10 to the 3rd times itself, okay? We're doing this twice. So 4 times 4 is 16, and 10 to the 3rd times 10 to the 3rd is 10 to the 6th. 16 is not in standard form. We need it to be an integer. So 1.6 times 10 to the 6th, which would give us 1 and 6/10 times 10 to the 7th. Or if we wanted to put it in standard form, we would write the original number. Okay, what about division? Let's look at division. How can we use the quotient of powers property to divide two numbers written in scientific notation? Okay, so what do we do here? Instead, we're going to divide the numbers and subtract the powers. Remember that rule when we were working with exponents. So here, we're going to divide the numbers, and we get 2.5. We're going to subtract the exponents, and we get -1 minus a -4, which is like adding 4. So -1 minus 4 is a 3. Now, this is not written in scientific notation. We need to move it 1 decimal point place. So that means what I would do is I would multiply 2.5 times 10 to the -1st power times 10 to the 3rd power, which would give me 2.5 times 10 to the 2nd power. Try these 3 for me, okay? I'll be back in just a second to go through the answers, so make sure you pause the video. All right, let's look at number 1's answer. If we divide, we would get 2. If we take 10 to the 6th power minus a -3, we get 10 to the 9th power. And it is in standard form, or excuse me, it is in scientific notation form, okay? I'm not going to review standard form on these. All right, with this one, we would divide 9 by 3 and get 3. 10 to the -3rd power minus 5 would be 10 to the -8th power. This was going to be a really small number, right, if we put it in standard form. And then for the last one, we would divide 1.5 by 3, and we get 1/2. And then 10 to the 4th power minus 6 would be 10 to the -2nd power. Now, that's a decimal. That is not an integer whole number in front of the decimal. So it needs to be between 1 and 9. So we're going to move the decimal point 1 place, make it a 5, which would be 10 to the -1st power to get it back to that form, times 10 to the -2nd power, or 5 times 10 to the -3rd power. And that's how we multiply and divide scientific notation. If you're having trouble with the exponents, you might want to go back and review that video. All right, see you next time.